Let's talk about reference angles. Okay, so what are reference angles? If you have an angle drawn in center position, then you can associate to that angle its reference angle. And the reference angle of that angle is the smallest acute positive angle formed by the terminal side of the original angle and the x-axis. And this is best understood with a picture. So suppose I have an angle. Let's say my angle is on the second quadrant, which is this one. Okay, so that's my angle, T. Then the reference angle of T, which some people call T prime, the reference angle of T is going to be the smallest angle formed by the terminal side, which is this, and the x-axis. So you see, when you consider the terminal side of an angle and the x-axis, there's always two angles formed, this one and that one. So whichever of the two is the smallest one, that's the reference angle. So that means that for this particular angle T, if you look at these two, the smallest is this one. So that one would be the reference angle in this case. And once we find the reference angle, we typically redraw it on the first quadrant. In this picture, we haven't done that, but typically once we find it, that's what we're going to do. Okay, so here's another situation that you could have, that the original angle is in quadrant 4. Then in that case, you see, suppose this is the original angle. That's the terminal side. So then when you consider the terminal side and the x-axis, there's these two angles formed. That one and that one. The smallest of the two is the reference angle. In this case, it would be this one. That one is the smallest of the two. That would be the reference angle. And so on. So wherever you are on the plane, you just have to consider the two angles formed between the x-axis and the terminal side of your original angle, and then whichever of the two is the smallest one, that's your reference angle. So let's do this one, for example. 210. What is the reference angle of 210 degrees? Well, the first thing you need to do is you're going to take a moment and you're going to draw a picture, and you have to make sure that you draw the angle in the correct quadrant. This is important. Okay, so remember that this is 90 degrees, this is 180 degrees, this is 270 degrees. And this one is either 0 degrees or 360. All right, 210 is bigger than 180 and smaller than 270. So that means that that angle, 210, is somewhere in the third quadrant. Okay, so if I draw the angle, that's my terminal side, that over there, that's 210. Okay, so now we're going to consider the terminal side of this angle, which is this, okay, and the x-axis. Note that there's two angles formed. There's this one right here, and there's that one. The smallest of the two is a reference angle. So that means this one, which is the smallest of the two, obviously, is going to be the reference angle. That's the reference angle. So what is the measure of that angle? What is the measure of that little piece over there? Well, if this is 210, what is that little piece? Well, how much after 180 do you go? You go another, to get to from 180 to 210, you go another 30 degrees, right? So what you do is you have 210, and then you subtract 180, and you have 30 degrees. That is this surplus, 30. You go 30 more after 180 to get to 210. So that right there is the reference angle. The reference angle of 210 is 30 degrees. Okay, let's do another one. What is the reference angle of 120 degrees? All right, first thing, draw a picture, making sure you draw your angle in the correct quadrant. So right now this is 90, then is 180, that is 270. Okay, 120 is bigger than 90 and smaller than 180, so it is somewhere here. Okay, so that would be 120. Okay, now we look at the terminal side of this angle and the x-axis and look at the two angles formed and see which one is the smallest one. So the two angles formed are, this is one, the original one, happens to be the original one, and then the small one, this one right here. So which one of the two is the smallest one? It is this one, and how big is that? If this is 120 and going halfway is 180, so what is this little piece over there? That would be 180 minus 120, which is 60. So 60 degrees is the reference angle of 180. All right, and what is the reference angle of 300 degrees? If you understood what we just did, the first two examples, you should pause the video and give it a shot on your own. Okay, assuming that you did that and we're back and you're done, let's do it. All right, so we're looking for the reference angle of 300 degrees and we need to take a moment to draw it in the correct quadrant. All right, this is 90, this is 180, this is 270, and that's 360. So 300 is bigger than 270, but smaller than 360, so that means 300 is somewhere in the fourth quadrant. Okay, so if I draw this angle, is going to look like this. And the angle 300 is right there. This angle right here. That's 300 degrees. Okay, now what? Now you consider the terminal side of the angle that you just drew, and the x-axis. Whatever is the smallest angle formed by the terminal side and the x-axis, and there's two, there's this one and there's that one, the smallest of these two is the reference angle. And in this case, that one is of course the smallest one, so that, whatever is the measurement of that, that is the reference angle. So if this is 300, how much more do you need to just complete the full circle? So what is the measurement of that little piece? Well, that should be 60, because 360 minus 300 is that little leftover over there, which is 60. So the reference angle of 300 degrees is 60. Okay, so these examples were all in terms of degrees because that's easier to understand, but it really is exactly the same if your angles were in radians. All you have to do is remember what these are in terms of radians. So this is pi over 2, this is pi, that's 3 pi over 2, and that's 2 pi. That's all you have to remember, otherwise you do it exactly the same. Alright, so what's the point of finding reference angle? Well, the point is that once you find, if you have an angle that is on another quadrant other than the first one, then you can use the reference angle to figure out the coordinates of the corresponding points of the unit circle for that angle. How? By referring to the reference angle. That's why it's called the reference angle. Okay, so let's do some applications of that. Here's the first example. It says here, we're going to evaluate all the 6 trigonometric functions at this angle without a calculator, okay, only by using the reference angle. Okay, so first off, start by drawing your picture. Actually, this we already did that one. This is precisely this one. So I'm not going to go through the process of doing everything again. The reference angle is 30. Okay, so it's on the third quadrant, and the reference angle is 30, and I draw it on the first quadrant. Okay, that angle over there is 30 degrees. And if you draw this correctly, it should look like a reflection, a reflection either across the x-axis up or horizontal across the y-axis or just across the origin. So this is a reflection across the origin or a double reflection. Okay. So once you have your picture, the idea is we want to figure out what the coordinates of this point are, because if we know the coordinates of that, we know the cosine and the sine of the angle. The cosine is the x-coordinate and the sine is the y-coordinate. So we really need to figure out what are the coordinates of that point. However, if we know the coordinates of this point right here, then we can figure this one, the coordinates of that one out, because it's going to be the same ones, it's on the other side, and it's a reflection through the origin, so the coordinates are going to be exactly the same, except with the signs have to be adjusted. And that's the idea. You see, the coordinates of this point are the cosine, sine, and because that's a special angle, you're supposed to really know these ones. You're supposed to memorize those or look them up. But the cosine of 30 degrees is square root of 3 over 2, and the sine of 30 degrees is a half. Okay? And now, as I said, the whole point is that if you know the coordinates of this point, then the coordinates of that one, you can figure them out because they're the same, except the coordinates have to be adjusted. This is in the third quadrant, so both coordinates are going to be negative. So this is the coordinates of that are then negative square root of 3 over 2, comma, negative a half. Aha. And what does that mean? That means that the cosine of 210 equals the x-coordinate, which is negative square root of 3 over 2, and the sine of 210 equals the y-coordinate, which is negative a half. See, and now we have figured out without a calculator, by knowing only the values in the first quadrant, what are the coordinates of that point, and therefore what is the cosine and the sine. And once you have the cosine and the sine, you can figure out all the other 4 trigonometric values by just using the basic identities, such as the reciprocal of the cosine is the secant. So that means the secant of 210 is the reciprocal of that, which is negative 2 over square root of 3. The reciprocal of sine is cosecant. So what is the reciprocal of cosecant? That's the reciprocal of negative a half. That's negative 2. Then we have the tangent. The tangent is sine over cosine. Okay, sine over cosine. Sine over cosine, sine is negative a half, and then the cosine is negative square root of 3 over 2. And then you simplify this, and let's do it real quick on a separate sheet of paper. So negative a half divided by negative square root of 3 over 2. Well, simplifying, this is times negative 2 over square root of 3. You can cancel the 2's, negative and negative, multiply it together gives you positive. So this is positive 1 over square root of 3. So this is 1 over square root of 3. Okay, and lastly, the cotangent is just the reciprocal of the tangent, which means the reciprocal of that. So that is square root of 3. And that completes the problem. You see, we figured out all of them by first figuring out the cosine and the sine, and then using the basic identities. Okay, let's do another one. Now this one using radians. Okay, so I'm going to start by drawing this picture right here. This is in radians, okay, so I better write everything in terms of radians. You could always change it to degrees and then write back to radians. That's too much work. You should become comfortable with both, so let's try to do it in terms of radians. Okay, you see, you have to just you can ignore basically the pi's and just concentrate on the coefficients. So this is 2/3 and this is a half. And this is a 1 and this is 3/2 and this is a 2. But 2/3 is bigger than a half. 2/3 is bigger than a half and smaller than 1. So that means 2/3 pi is actually then somewhere here. Okay, 2/3 pi is somewhere there. That's 2/3 pi. All right, and then what is the reference angle? The reference angle is the smallest angle formed by the x-axis and the terminal side. So in this case, it's that one. All right, and what is that? Well, that is, this is a little piece that I need. This is like, if you go 2 pi over 3 here, what do you need? How much more do you need to get to pi? Well, it's a difference. So it's going to be pi minus 2 pi over 3, which is 3 pi over 3 minus 2 pi over 3, which is pi over 3. So that means the reference angle is pi over 3. Okay? Reference angle is pi over 3. Now let's take a moment and draw that again. You could draw it over there, but it's kind of too cluttered. I like drawing it in a new picture. So I have then 2 pi over 3, and I have pi over 3. So if I know the coordinates of that point, I can figure out the coordinates of this one, because it's going to be the same coordinates as the reflection. It's the same coordinates, but with the signs adjusted. Okay, and that's the whole point of this. So what are the coordinates of that, though, of this point? Well, is the cosine, the x-coordinate is the cosine, so cosine of pi over 3. The y-coordinate is the sine, so sine of pi over 3. And what is that? Well, you're supposed to memorize this. Look it up in the table until you do. So cosine of pi over 3 is a half, and sine of pi over 3 is square root of 3 over 2. Now, if you know these coordinates, those are exactly the same ones, but signs adjusted. So the x should be negative, the y is the same, because you're in the second quadrant. And what does that mean? That means the cosine of that angle is the x-coordinate, and the sine of that angle is the y-coordinate. In other words, the cosine of 2 pi over 3 is the x-coordinate. The sine of 2 pi over 3 is the y-coordinate. Okay, and these are the main two. All the other four trigonometric values, you can figure them out from these two. So let's do it. The reciprocal of the cosine is secant. So secant of 2 pi over 3 is the reciprocal of that, which is -2. The cosecant is the reciprocal of the sine, so the reciprocal of this, which is 2 over square root of 3. And the last two, tangent. Tangent of 2 pi over 3. Tangent is sine over cosine. So really, sine over cosine should be square root of 3 over 2, all that over -1/2 sine over cosine. And then you simplify that, and that gives you negative square root of 3. And lastly, cotangent of 2 pi over 3 is the reciprocal of this, which is -1 over square root of 3. All right? Okay, we're going to do more examples. If you understood those really well, then you can try the next ones on your own. But if you did not get that, if you're not comfortable quite yet, then let's do another one together. Okay, so this one. This one says, consider the angle 855. We're going to use the reference, we're going to first find the reference angle, and then we're going to use that to rewrite the expression cosine of theta. So the first thing we want to do is find the reference angle. Okay, remember you find the reference angle using the terminal side and the x-axis. Now this angle is too big, it's huge. So what you do is you want to bring it down, and remember this is how we started the semester. This was lesson 1. So if an angle is too big, you bring it down. How? By subtracting 360. In other words, we're finding a coterminal angle. So this angle is too big. Subtract 360, and that gives you a coterminal angle. And let's put it in the calculator real quick. What do you get? You get 495. So subtracting 360, like they say, doing a 360 just puts you back right in the same spot. So this angle has the same terminal side. Now that's still too big. That's bigger than 360. So let's do it again. So 495 minus 360 is 135. Okay, that's a lot better. Now let's find the reference angle of that. Okay, let's draw the picture. That 135 is bigger than 90, but smaller than 180. So you're somewhere here in the second quadrant. Okay, that's the same. That's 135. And now what is the reference angle? Well, the reference angle is the smallest angle between my angle, 135, and the x-axis. The smallest angle is this one in this case. And what is that? What is the measurement of that? That little piece over there? Well, it should be 180 minus 135, which is 45. So the reference angle is 45. This is the reference angle of both 135 and the original one, 855, because both have the same terminal side. Okay, now that you found the reference angle, we're going to rewrite the expression cosine of theta in terms of that. Okay, so let's draw another picture. So this one right here is same as 135, but it's also the same as 855. So the coordinates of that point is going to be cosine of 855 sine of 855. X coordinate and Y coordinate. So that's that point right there. Now, the reference angle is right over here, 45 degrees. So the coordinates of that point are cosine of 45 degrees, sine of 45 degrees, which is a special angle. You're supposed to memorize that or look it up until you do. That's square root of 2 over 2, square root of 2 over 2. Although we're not going to use that yet, but that's what it is. You're supposed to know that. For now, we just want to rewrite it in terms of cosine, but of the reference angle. Okay, so we're just going to concentrate on that. Now, if you look at the compared coordinates, the cosine of 855 is the same as the cosine of 45, but negative. In other words, cosine of 855 is the same as negative cosine of 45 degrees. And that is the answer. So rewrite cosine in terms of another cosine, but using the reference angle instead. Well, comparing the x-coordinates, which is the cosines, the cosines are the same except this has to be negative. So this one is negative that one. Okay? And now is when we use this information to answer the second part. What is then cosine of 855? Well, we just said that it is negative cosine of 45. And up here we said it is cosine of 45 is square root of 2 over 2. So cosine of 855 is square root of 2 over 2. Okay, we're going to do one now with radians. Let's do that. Okay, consider the angle now 19 pi over 6. We're going to rewrite the expression tangent of theta in terms of the angle's reference angle. Okay, so first thing we want to do is find the reference angle. 19 pi over 6, that's bigger than 2 pi. So that 19 over 6 is bigger than 2. So that angle is too big. We need to bring it down by finding a coterminal angle first. So bring it down by subtracting 2 pi. And this is then going to be 19 pi over 6 minus 12 pi over 6, which is 7 pi over 6. Okay. 7 over 6 is smaller than 2, so that's smaller than 2 pi. Okay, so that means we're now in a good place. Okay, 7 over 6 is a little over 1. 7 over 6 is a little over 1, so that means 7 pi over 6 is a little over pi. So that means we are in the third quadrant. Okay, so this is pi, and this is 3 pi over 2. And 7 over 6 is a little over 1, but smaller than 3/2. So we're right here. That's that angle right there is 7 pi over 6. Okay, now we're supposed to find the reference angle. The reference angle is the smallest angle formed by the x-axis and the terminal side of my angle, which in this case is this one right there. This one, okay? So what is that little piece over there? What is that little piece over there? Well, that little piece is 7 pi over 6 minus pi. Because it's bigger than pi, you went over it by a little bit. By how much? Well, is a difference. And subtracting pi is the same as subtracting 6 pi over 6. So this is just pi over 6. Okay, so that's the reference angle. And now we're going to use that to rewrite our expression. So we have that, and that angle over there is pi over 6. Remember, if your picture is good, it should look like a reflection either across the x-axis or across the y-axis, or a double reflection, or a reflection across the origin. Alright, so this one is 7 pi over 6. Alright, so then, let's do it. What is this? We got, first of all, tangent of 19 pi over 6 is the same as tangent of 7 pi over 6, because these are coterminal angles. They have the same values. Right? When you have coterminal angles, you're in the same spot. You're gonna get the same values for everything. Okay, so then what is tangent? Tangent is sine over cosine. But what is sine of 7 pi over 6? Well, sine of 7 pi over 6 is the y-coordinate of that point, and the cosine is the x-coordinate of that point. Right? That's what these are. So this is cosine of 7 pi over 6, sine of 7 pi over 6. But if we compare with these coordinates with those coordinates are exactly the same as those coordinates, but both are negative. What are the coordinates of that one? Well, the coordinates of that one are cosine of pi over 6, sine of pi over 6. So that means these numbers are exactly the same as these ones, but both negative. In other words, sine of 7 pi over 6 has to be the same as this y has to be the same as that y, but negative. So this is negative sine of pi over 6, and this cosine has to be the same as that cosine, but negative. So this is negative cosine of pi over 6. Okay, this is equal sign over here. Okay, and then negative divided by negative gives you positive. So this is positive, canceling just the negative sign. Sine of pi over 6, cosine of pi over 6. But sine over cosine is the tangent. So you get tangent of pi over 6. So that means the tangent of 19 pi over 6 equals the same as the tangent of pi over 6. And now we're going to finish it off by actually evaluating it. The tangent of 19 pi over 6 is actually the same as tangent of pi over 6. And what is the tangent of pi over 6? Well, tangent is sine over cosine, which is really this, okay, what we had written before above. And these are special angles. These are in the first quadrant. You're supposed to memorize them. Sine of pi over 6 is a half. Cosine of pi over 6 is square root of 3 over 2. And simplifying this is a half times the reciprocal of that, which is this. The 2's cancel and you get 1 over square root of 3. Okay, and here's the last example. Now really, you should really try the very last one. Using the reference angle, find the exact value of cosine of 150 and the exact value of sine of 5 pi over 4. Okay, pause the video and give it a shot. And assuming that you did that, so let's go back here and do it. We have to figure out what is the cosine of 150 degrees. So what I'm going to do is first draw 150. 150 is between 90 and 180, so it's on the second quadrant. The reference angle of that is this. Okay, so this is 150. And this little piece over there is the difference, so that's 30. So 180 minus 150 is 30 degrees, which is the reference angle. So that's the reference angle, 30. And now, if I'm looking for the cosine of that angle of 150, the cosine is the x-coordinate of that. But I can figure out what is the x-coordinate of that and even the y-coordinate if I know the coordinates of this one. The coordinates of this one, the coordinates of that one are cosine of 30, sine of 30, which is square root of 3 over 2, sine of 30 is a half. But now, if I know the coordinates of that, I can figure out the coordinates of this one, and in fact, they're exactly the same with signs adjusted. The x-coordinate needs to be negative because if you're in the second quadrant, okay? So that means the coordinates of this point are negative square root of 3 over 2, a half. What does that mean? That means the cosine is negative square root of 3 over 2, and the sine, which they're not asking about, is 1 half. So let's write that down. The cosine of 150 is negative 3 squared over 2. This is what the question was. And even though they're not asking about this, let's write it down. The sine of 150 is actually half that one. Okay, and now let's do the very last one. Five-fourths is a little over 1. So 5 pi over 4 is a little bigger than pi, but less than 3 pi over 2. So you're actually in the third quadrant. And if you're in the third quadrant, this is the reference angle right there. That's the smallest angle between the x-axis and the terminal side of your angle. And what is that little piece over there? Well, from here to here, like that, that's 5 pi over 4. You went past pi by a little bit. By how much? By the difference. So it would be 5 pi over 4 minus pi, which is pi over 4. So that is the reference angle. And if that is the reference angle, we can figure out the coordinates using that reference angle. So this is the coordinates I'm looking for, and the reference angle is that one there. Again, remember, it should look like a reflection. in this case across the x-axis, across the origin. All right, so that is 45 degrees. If that is 45 degrees, that means the coordinates of that point, this is a unit circle, the coordinates of that point are cosine of 45 degrees, sine of 45 degrees, which is a special angle. You have to memorize that or look it up until you do. Square root of 2 over 2, square root of 2 over 2. But if I know the coordinates of that, being those, the coordinates of this one are exactly the same, signs adjusted. So the coordinates of that point over there are negative square root of 2 over 2, negative square root of 2 over 2. And what that means is that the cosine is this and the sine is that. So let's write that down. The cosine of my angle, which is this one. Oh, yeah. 45 degrees is pi over 4. Okay, cosine of 5 pi over 4 is what? Negative square root of 2 over 2. And then sine of 5 pi over 4 is negative square root of 2 over 2. They were asking about only the sine. So this is